Good morning, everyone. Bon dia. Okay, I'll start with the standard disclaimer slide. Please review these messages. They're very important. Okay, so let me start by presenting a couple of scenarios to you, which our customers have often discussed with us. There are some VMs in my cluster which experience periodic resource usage surge, and this results in application performance drop briefly in other VMs in the same cluster. Another case, we tend to often reserve capacity for VMs based on their peak workloads, while the average workloads are much lower. This obviously leads to inefficient resource usage in the cluster. Now, if you look closely, the underlying problem in both these scenarios is very similar, and that is occasional resource contention. Now, how do we address resource contention in general? We can react to resource contention if it happens, or we can be proactive about it and try to do something before it happens. In reacting to resource contention, we generally vMotion virtual machines across in the same cluster after the contention happens. The good thing is there's minimal overhead there. We only move VMs that absolutely need to be moved. Right? But the downside is that some VMs might experience performance drop because the remediation is happening after the contention has already started. Now, how can we be proactive about this? As I discussed in one of the cases, we can statically allocate more resources so that you are sure that there is no resource contention. Right? But over-provisioning is obviously not a good idea. So, what can we do? We can learn the workload patterns in your VMs and try to do something about the workload surges before they actually happen. So, this is great because there's not going to be any performance impact on your VMs, but this is good for VMs which have regular periodic workload patterns that can easily be learned. We cannot account for unexpected short-term spikes in resource usage, and we cannot predict events in your cluster that could lead to cluster imbalance, eventually leading to resource contention. So then what's the solution? Right? The best approach is to predict future workloads by learning them and by reacting also to short-term spikes and addressing the future demands as well. And this is precisely what Predictive DRS does. It's a new feature in vSphere 6.5 and vRealize Operations Manager, or VROps 6.4. So welcome everyone to this breakout session on Predictive DRS, performance, and best practices. I'm Adarsh Jagadishwaran, and my colleague here, Sai Inabatini. The two of us work on DRS performance. We are from the performance engineering group in VMware. We primarily focus on the DRS algorithm, its performance and effectiveness. Okay, quick show of hands. How many of you here have been using Predictive DRS? Okay, I see a couple of hands go up. Okay, that's good. So it's a relatively new feature, as we all know, right? So the agenda for today's session was to introduce Predictive DRS, this feature to you guys. It's good because not many people are using it yet. Right? And also, we want to go over some configuration and basic software requirements that will help you get started with the feature. And then Sai will present to you guys some case studies that will help you understand why Predictive DRS is useful for you. And we'll cover some frequently asked questions about Predictive DRS before we conclude the talk. Okay, so what is Predictive DRS? We are all aware of vSphere's flagship resource scheduling algorithm, DRS. The same DRS enabled with predictions is what Predictive DRS is, simply put. It comes with the powerful resource scheduling of DRS and analytics from VROps. So Predictive DRS enables VROps to provide long-term forecasting metrics to augment the short-term placement criteria of DRS. In other words, Predictive DRS uses both the proactive and the reactive approaches to balance your cluster load, and to also take care of short-term occasional resource contention. So how does predictive DRS work? In a nutshell, this is the workflow that predictive DRS follows. So it all starts with vCenter server collecting resource usage data for all of its virtual machines and hosts that it manages. So this resource usage data is then sent to VROps. VROps does a lot of analytics, sophisticated analytics using machine learning algorithms on this data and understands the patterns of the workloads in those VMs. And it then comes up with long-term predictions of the resource usage. Then it filters these predictions to make sure that it's only looking at the most reliable predictions, and then sends them back to vCenter server to be consumed by DRS. DRS in turn will use these predictions. It will also look at the current workload demand in the cluster and use both of these data to come up with the final vMotion recommendations in order to balance the cluster load. So as you see, like if you follow the workflow here, you will see that in the end, DRS is coming up with load balancing decisions, taking into account the current demand in the cluster as well as future long-term predictions that VROps is sending it. Okay, so now let's take a look at the predictions aspect of predictive DRS. Another quick show of hands. How many of you here have used vRealize Operations Manager or VROps? Wow, that's a sizable number. Okay, thanks. So those of you that have used VROps, you must be familiar with the term dynamic thresholds. So this dynamic thresholds is what VROps is using to come up with predictions for predictive DRS. So VROps, as you might be aware, does a lot of sophisticated analysis using many different machine learning algorithms on the resource usage data that it gets from vCenter server. And then it learns the normal behavior for every metric and every object that it manages. From this data, it detects the hourly, daily, and monthly patterns of resource usage. And then it determines the upper and lower bound of the normal distribution. And this is what it calls the dynamic thresholds. Right? It then polishes this DT and filters it to come up with the final set of predictions. Now, this is important. The reason why we need to polish and filter all of these predictions is, as I said before, we need to make sure that only the most reliable predictions are sent back to vCenter server. Because if you can imagine, if we start reacting to short-term spikes, which is very common in the real world, and make vMotions based on those short-term spikes, then we will not be doing a very good job because that might again lead to problems in terms of VM suffering because of unwanted vMotions. So we need to be absolutely sure that we are sending the right predictions, the most reliable ones, the ones that we have learned after a lot of learning period, back to DRS. All right, so now that we have learned how predictive DRS works at a very high level and how the predictions are generated in VROps, let's take a look at what we will need to get started with this feature. The first thing, vSphere 6.5, with Enterprise Plus license, you will get predictive DRS. On the VROps side, predictive DRS was supported starting from version 6.4. In 6.4, VROps supported 4,000 VMs in a single cluster for predictive DRS, but that limit was removed starting from version 6.5. So in summary, if you have vSphere 6.5 with Enterprise Plus license and VROps 6.4 or above, then you already have predictive DRS. You just need to enable and start using it. Okay, so now how do we configure predictive DRS as a feature? Because you have two different products that that this feature spans. So on the vSphere side, you need to enable the option in vCenter server. So you need to go to your cluster under the Configure tab for vSphere DRS. You need to enable a checkbox. That's it. But you need to make sure that you sync the clocks between your vCenter server and your VROps server. This is very important because the predictions that VROps is sending to vCenter server, they are time-based. So if the clocks are not skewed between the two servers, the predictions that are coming in from VROps will not make sense for vCenter server. So for this reason, vCenter server will just discard any predictions coming in from VR ops if the time skew between the two machines is more than 5 minutes. On the VR ops side, you need to enable the vCenter server adapter to provide statistics to predictive DRS. So in the configuration for the vCenter server adapter, under advanced settings, you need to enable the option to provide this data to predictive DRS. Okay, so now that we have learned how predictive DRS works and how do you configure it to get started, let's take a look at some of the case studies to help you understand why you will need predictive DRS. Over to Sai.
Thanks, Adarsh. It's audible, right? Yeah. Okay, so we have seen like what is predictive DRS and how to configure it so that you can get started. Now let's get to the point. Adarsh mentioned like predictive DRS is actually built on top of existing DRS. So when it comes to the performance of predictive DRS, it's no different from DRS because it's already built on the same logic. So then you must be wondering, what is the additional benefit my applications or VMs get if I enable predictive DRS? Let's take a look. So for this case study, we've used the follow the sun scenario. So follow the sun is a typical DevOps scenario where people work in different time zones. So all the applications run on the same hardware, but those VMs are used by people sitting in 3 different time zones. In this case, I chose 3 different time zones, type A, B, and C. So each type represents people logging in from different time zones, but all the VMs are running on the same cluster. So they essentially share the same hardware. And I chose the workload duration is as 8 hours to pretend it's a 9 to 5 scenario. If you look at this point, all the type B workloads start at this point, and type A workloads ends at this point. So there is a brief duration where type A and type B run together on the same hardware. So this is the point of impact. At this point, when people in different time zone, when they come to the office in the morning at 9 o'clock and they try to log into their applications, at this point, there will be a sudden increase in the resource requirement on the cluster because all these new type B applications will start asking for more resources. So at this point, there is a good chance that your cluster may go out of balance and your cluster may also have contention, depends on the kind of imbalance that gets created, and that could potentially translate into application performance impact. So I'll take this point and I'm going to show you how enabling PDRS will help you totally avoid the contention so that there won't be any performance impact at all. So let's take this point. And I have 2 cases here. First, impact of predictions on type A workloads. Remember, the type A ones are already running on the host or running on the cluster, and impact of predictions on the type B workloads. So these are the ones that are about to start. So when contention gets created, it's going to impact both the ones that are about to start and the ones that are already running. And the benchmark we used is DVD store in this case. So for those of you who are not familiar with DVD store is OLTP benchmark load. It's primarily CPU intensive one. So if you see all the charts that I'm going to show you, mostly I'm going to talk about the CPU workload because the benchmark I used is CPU intensive one. And the end of the benchmark run, it gives you a throughput as transactions per minute. And the VMs we used are the Windows ones with general Windows applications, and the DVD store ones. DVD store ones is to run the DVD store benchmark. Okay, let's get to the case 1. So I have initial state like this. I have 4 hosts, and if you can see, all my hosts are around like 20% utilized. So overall, the cluster utilization is relatively low. But when we look at the VMs distribution, this is what my VMs distribution is. If you see, there are 4 hosts, and each green block on each host represent a VM. And the size of the block represents its workload. If you see, on all the 4 hosts, there are blocks which are bigger in size, and there are multiple smaller blocks. So these multiple smaller blocks are type B VMs, and they are idle right now. They're not running anything. And they're about to start its workload soon. So in this case, in my case, in this particular example, they are the Windows VMs. And the other ones which are already running, they represent type A because they're already running, and you can see the size of the block is bigger because there is some workload that's running inside these VMs. So in this example, they are DVD store VMs. So this is the scenario on the vCenter. Let's see what's happening on the VROps. On the VROps, so my VROps has predicted for all the VMs that are idle, the type B ones, VROps has predicted that their workload is going to start soon, or the resource requirement or the resource demand is going to increase. So this is a prediction chart for one of the VMs, one of the idle VMs. This is, you can see it's a Windows VM. And if you can see inside the green circle, that is what the predicted workload. The dark blue line represents the current load, and the one inside the green circle, which is in gray color, that is the predicted workload for this VM. So VROps has predictions for all the VMs, all the VMs that are idle right now. So once VROps has these predictions, then it sends them back to the vCenter. Once the predictions are available on the DRS or vCenter, DRS consume them, and you can see in PDRS disabled case, there are no predictions, there are no recommendations, because you can see the workload is almost like 20% on each host. So there is no need for extra recommendations. But when enable PDRS, you can see DRS started to recommend moving VMs. And the primary reason for this is the predictions that are coming from the VROps. So whatever the predictions whatever the recommendations that DRS recommended, I applied all those recommendations. And let's take a look at the final state. Final state after all the type B workloads start. So this is how it looks like when I don't have PDRS enabled. You can see all these type B applications have started on the same host. So there is a sudden increase, cluster is out of balance, and one of the hosts is suffering because there is a resource shortage. And when I enable PDRS, since we proactively distributed the workloads or distributed the VMs even before the workloads start, you can see there's no contention. This is primarily because we migrated the VMs proactively so that whenever the workloads actually start, we can handle the load. Okay. Now let's see how whatever the resource contention that happened, which I showed in the last slide, has actually translated into application performance. If you look at the DVD store throughput charts, this is what we have seen. Again, I have two runs here. The green one is without predictive DRS, and the blue one is with predictive DRS. You can see at this point, the type B workloads start. So at this point, there was a contention. When all these type B VMs start, there was contention that created at this point. And without PDRS, since there was contention, my application performance has dropped. And that is the dip in the curve, the green one. And at this point, DRS remediated the imbalance or the contention, because DRS reacts to the contention that happened, and then it tries to distribute the load. So it took some time for the DRS because it has to move a lot of VMs out. So in my case, if you see the duration between the two arrows, it's around 3 to 4 minutes. It all depends on the kind of contention that gets created in your cluster. If there is a lot of contention and there are a lot of VMs that needs to be moved out, this could be even more. But on the other hand, if you look at the blue line, which is when predictive DRS enabled, it's more of a straight line because there was no contention. Okay, so let's look at the second case. How is that having predictive DRS or enabling PDRS will help the type B workloads, the workloads that are about to start? I have a similar initial state where I have 4 hosts, and mostly the cluster is underutilized. But when we look at the VMs distribution, again, there are a lot of VMs that are idle right now. Again, the ones that are already running, these are the type A ones. They represent, in this case, they are Windows. And the ones that are idle, the smaller blocks, they are type B ones. In this case, they are DVD store because we wanted to measure the performance impact on type B workloads. So that's why DVD store are the type B ones here. So this is what's happening on the vCenter. And when we look at the VROps, again, VROps started sending us the predictions. This is prediction chart for one of those DVD store VM, which is idle again. And its workload is going to start in a few minutes. So once these predictions are available on the VROps, these are sent to the vCenter. And on the DRS side or vCenter side, DRS again recommended to move a lot of VMs out of this host. Because VROps has recommended, there is a workload that is going to start in most of these VMs. So distribute these VMs so that when actually the workload starts, there won't be any contention at all. So I applied all the recommendations that PDRS or DRS recommended. And when we looked at the workload state or the cluster state, this is what it looked like when I disabled PDRS, because all these VMs started on the same host. And in PDRS enabled case, since we proactively distributed the VMs onto different hosts, there was no contention at all. And if you see how this is actually translated into application performance, this is what DVD store throughput chart says. Again, we have two runs, the blue one and the green one. So the blue one is without predictive DRS, and the green one is with predictive DRS. At this point, when all the type B applications start, in the blue case, that is when I don't have predictive DRS, you can see the throughput is around 3000 ops. That's because there was contention. When all the applications start, there was contention on the host, so the applications could not get whatever the resources they need. So the throughput is around 3000. But if at the same point, if you look at the green line, that is when I have predictive DRS enabled, the throughput is around 5000 ops. That's because there was no contention at all, so my application started at its peak load. And at this point, DRS remediated the imbalance, whatever that was created. And in this case, it took some time for my application to actually stabilize and go back to its peak load. So overall, my applications have suffered around 4 to 5 minutes in this case because of the contention that was created. And that was totally avoided when I have predictive DRS enabled. So what do we infer out of this, out of these two scenarios? I would say predictive DRS will prepare your cluster for the upcoming resource requirement even before your application performance drops, so that you can totally avoid any performance drops during these occasional resource contentions. Okay, so it's not just load balancing. There is an extra perk that you'll get if you have predictive DRS enabled. So let me ask you a quick question here. How many of you are actually using DPM? Anyone using DPM? No one? Okay. Okay, so let me briefly talk about what is DPM, and then I'll talk about what is the extra perk you'll get. This is for free anyway. Okay, so DPM is the cluster level power management engine that provides you additional power saving. So the way it works is, it monitors your cluster usage or your workload usage, and it dynamically consolidates the workloads onto fewer hosts so that it can turn on the unnecessary host, it can turn off the unnecessary host so that you can save power. So it migrates these virtual machines onto fewer hosts, and the unneeded ESX or the hosts that are not required right now can be put into standby mode so that you guys can save power. And when the workload demand actually increases, DPM reacts to it and ESX hosts are powered back. So I want to talk about this last statement. So when the workload demand increases, whatever the hosts that are powered off by the DPM will be powered on back so that it can accommodate the increased demand. If you see this statement, this is a reactive statement. Like when the demand increases, my DPM will react to it, and then it will pick which host needs to be powered on back, and then it will try to power them on. So for this whole process takes some time after the workload demand increases, because it has to react to it and then it has to power on the host. So during this brief duration, if whatever the contention that happened in your cluster or imbalance that happened, if it is a lot, it could potentially impact the application performance as well. But what if the DPM can take advantage of these predictions, and can it power this host proactively even before the workload demand increases? And that's what DPM will do. So let me illustrate this with a simple example again. I have 4 hosts, similar 4 hosts, and all my applications can run safely on 3 hosts. So DPM has put one of the hosts into standby mode. You can see like all the hosts are around 40% utilized. So since all the applications can run on 3 hosts, DPM has put one of the hosts into standby mode. And on the VROps side, VROps has predicted that, and this is a prediction chart for one of the VMs running on this host. So VROps has predicted that some of the VMs that are idle right now and their workload is going to increase. So that's what VROps has predicted, and it sent those predictions to the vCenter. Once these predictions are available on the vCenter, it's not just the DRS, DPM also consumed those predictions, and it started to recommend to power on the host. You can see that absolutely there is no need for extra host in my case, because all the hosts are like 40% utilized, they're running fine. But at this point, DPM has actually recommended because of the predictions that are coming from the VROps. Okay. So whenever I talk about predictive DRS, people usually ask me same set of questions. So I thought it would be better if I can address some of them here. And these questions will also help you to understand the predictive DRS better. So let's look at these questions. So what workloads PDRS can predict? Are there any workloads that PDRS cannot predict, or are there any workloads that PDRS can predict better? So the simple answer to this question is any type of workload with periodic usage pattern can be predicted. When I say periodic usage, if the workload is having short spikes of the minute order, for example, short 5-minute spikes, those spikes will not be predicted. And it makes sense, right? Most of the time, these short 5-minute spikes represents an occasional or unexpected spikes. We don't want your VROps to predict those unexpected or occasional spikes, account them into consideration, and then recommend migrations based on these unexpected 5-minute spikes. And more consistent your workloads and more consistent your workload patterns are, more accurate your predictions will be. For example, all your workloads will start around 9 o'clock on the day, on a weekday, and then ends around at 5 o'clock. That's more consistent pattern all the time. So those kind of workloads will be predicted more accurately. Learning period. So Adarsh referred in the beginning, so the VROps takes all the resource usage data from the vCenter, and then it uses its sophisticated analytic algorithms, and then it starts to generate these dynamic thresholds. So how long will it take for this whole process so that I can have predictions for my VMs? So that is generally referred as learning period. So the amount of time that VROps takes to learn your workload pattern and to start generate the predictions. So by default, this learning period is 14 days. And the reason for this is 14 days is because we have tested with a lot of different types of workloads, and then just to make sure we are on the accurate side, whatever the predictions that we generate are very accurate, because based on these predictions, we are going to recommend further migrations. So just to be whatever the predictions that we generate are more accurate, we've set the learning period to be 14 days. You can change this, and I'm going to show you how you can change this if you want. If you want your PDRS or to recommend predictions before 14 days. But longer the learning period, it's always better or more accurate the predictions will be. So if you have predictions after 14 days and you have predictions after 28 days, the predictions that you get after 28 days are definitely more accurate than the ones that you get after 14 days. Because it's machine learning algorithms. The more data you pump in, the more accurate the predictions will become. And predictions will be available only after 14 days. This is by default, that's what I mentioned. So if you added your vCenter to VROps like 2 days ago, and if you don't see predictions, it's not a surprise because there's not enough data at the VROps to start generating predictions. So it at least needs 14 days of data by default before it can generate predictions. And current demand versus future demand. So some customer has asked me, this is all fine, and what is the weightage that PDRS considers when it takes my current requirement and the future requirement into consideration? For example, currently my VM requires 90% of CPU, and in the future, let's say in the next 1 hour, it requires only 40%. So how does it weigh? So what is more important here, my current requirement or the future requirement? So to answer this, PDRS will always ensure your current VM requirement or current VM demand will not be affected at all to favor the future requirement. So this will ensure your current VM performance will not be affected at all. So the way it considers the VM demand is, it always considers the maximum of current demand and the future demand. So it takes the conservative approach. So the bottom line here is, current demand of your VMs will not be clipped to favor the future requirement. So this will always ensure current VM performance will not be hit. Tuning. I mentioned you have to wait for 14 days, or VROps have to wait for 14 days so that before it can start generating predictions. And you can change that, I said. So how do you do that? So if once you added your vCenter into VROps, so if you navigate through this administration support and there's a tab dynamic thresholds, there you see a button says start generating dynamic thresholds. So you can manually force the VROps, if you want right now, after 2 days of data, you want to see how the predictions are, you can manually force the VROps to generate the predictions using this button. And there is something on the vCenter side. So there is something called look ahead interval. So this look ahead interval is the amount of time DRS looks into the future before it starts to recommend any vMotion. Let's say, what is the current, whenever DRS runs, it considers what is the current requirement for the VM and what is the requirement for it in the next 1 hour. So this next 1 hour is the look ahead interval. By default, this is set to 1 hour. You can again change this using a DRS advanced option in case you want your DRS to look into the next 6 hours before it starts recommending any vMotion. And you can set it up to 12 hours. Okay. I said your VROps has to wait for 14 days before it starts to generate predictions. So what if you're deployed, you have VMs, like 100 VMs in your cluster, and 50 of them are running for the last 30 days, and the other 50 you just deployed like 2 days ago. So VROps do not have enough data to generate predictions. So your cluster might often end up with a mix of VMs. Some VMs with predictions, some VMs without predictions, because they are powered on very recently. So in that case, it's pretty simple and straightforward. The way PDRS considers the VM requirement is, when your VMs have predictions, VM demand is always the maximum of current and the future requirement. And if your VMs do not have predictions, it will simply be the current demand. Okay, so filtering the predictions on the VROps side. Not all the workloads are the same, right? There are always certain workloads that are unpredictable. They are always volatile. And most of the times, these workloads run alongside with the normal workloads. So what happens in these scenarios? What if the VROps can send predictions for these workloads which are not very accurate? Are they going to affect my whole balancing act? No. So the way VROps sends these predictions is every day, like once a day, it sends the predictions for the next 26 hours in time. For these 26 hours, there will be 52 samples. So each sample represents 30-minute duration. So once a day, every time VROps sends these predictions, it sends 52 samples. Each sample represents a 30-minute duration. So each of these 30-minute sample, before they send to the vCenter, they'll go through a filtering logic that is there in the VROps. So whatever the samples that do not meet the accuracy criteria will not be sent. They'll be discarded. And if there are any samples that are identical, the consecutive samples that are identical, for example, morning 7 o'clock to 10 o'clock, the predictions are the same. Morning 7 o'clock to 10 o'clock, the predicted CPU usage is 50%. So instead of sending 6 samples, it will send only one 3-hour sample. Okay, the last one. So how can I differentiate or identify vMotions that happen due to predictions? Because, and predictive DRS is a relatively new feature. All of you wanted to try out and see, enable PDRS and see what are the additional vMotions that are happening because of PDRS. I want to differentiate. If I enable PDRS now, I'll get 6 vMotions. If I don't, I get only 3. And if you want to differentiate these numbers, there are actually 2 cases for this. Case 1, it is not often possible to differentiate the vMotions that are happened due to predictions. And case 2, you can do that. So let's talk about case 1. Why did I say it's not often possible to differentiate vMotions that happen due to predictions? I'll explain this with a simple example. Let's say I have 2 hosts, A and B, and I have 3 categories of VM here. The red ones do not have predictions, that's why they are red, and the green ones have predictions, and I have blue ones as well. So these blue ones are the VMs with predictions dropped. When I said dropped, because the future requirement is less than the current requirement. I mentioned PDRS will always consider the maximum of current and the future requirement. So if the future requirement is less than the current requirement, it just considers the current requirement. So this is the cluster I have. And at this point, the resource demand on host A has increased. This is because the green ones, which have predictions, and the red ones, which do not have predictions, are started asking for more resources. So that's why you see the resource demand on host A has increased. So cluster went out of balance. So DRS has to move some of the VMs out. So DRS moved blue VMs out of host A into host B. And the reason why DRS shows the blue ones is just moving these blue VMs will balance the cluster faster. So in this case, if you see the blue VMs are moved. So why are the blue VMs moved? Is it because of predictions or not because of predictions? If you look carefully, the whole reason why blue VMs are moved is because there is increase in demand on host A. And that increase in demand is contributed by the green ones and the red ones. So in this case, we cannot clearly differentiate why the blue VMs are moved, because the VMs with predictions and the VMs without prediction has contributed for that migration. This is case 1. Let's talk about case 2. Okay, I have only the green ones in the cluster. All my VMs in the cluster have predictions. Then it's easy to differentiate. But unfortunately, you cannot do that right now from the UI. You can do it through the logs. Hopefully, you can see this information in the UI in the future. So let me conclude with these 4 thoughts. PDRS can help avoid the contention even before your application performance drops. And the way it does is because it proactively prepares your cluster and distributes the workload so that when the actual workload starts, all of them will not power on the same host. And forecasting in PDRS works best for periodic workload patterns. Like I said, most of your applications start around morning sometime and then they end evening at some time. So those kind of periodic workloads, PDRS works best. And the current demand of your VMs will never be clipped to favor the future requirements. So this is to ensure that whatever the predictions are, your current VM performance will not have any impact. And lastly, PDRS provides the best solutions because it uses a balanced approach of predicting the future requirement at the same time reacting to the unexpected spikes. Okay, we also have a few links. These are not directly related to PDRS, but these will give you a more insight into how DRS works. So first one is DRS Lens. So it provides you a simple user interface and very effective. So you can see all the DRS related activity in one UI. And we have another link, DRS Dump Inside. In any case, if you wanted to know how is DRS working, what are the different moves DRS considered before it recommended me these vMotions, or why it recommended these vMotions, so you can use the second link, which is a Dump Inside. This is a service portal where it will ask you to just upload some log files and it will give you a detailed report. Okay, we have a time, like we have around 20 minutes for Q&A. In case you guys have any questions, please. Yeah, 1 second.
There are some mics going around, so you can pick one of the mics and.
Is this CPU and memory only, or are you guys looking at network bandwidth as well?
Right now it's CPU and memory only. Yeah.
Any questions?
CPU and memory only right now.
Yeah.
Okay. Is it in the roadmap to look at network bandwidth like regular DRS?
Not right now. Maybe in the future. Yeah.
Okay.
Not right now.
Thank you.
Yeah.
Hi, I've got a question.
Over there. Yeah.
There's a question.
The software requirements, was it vCenter 6.5 or ESX 6.5?
Oh, vCenter 6.5.
6.5. And another question, does this give predictions on cross-cluster?
No, this
is right now, it's intra-cluster.
It's just the cluster?
Just in the cluster.
Is there any plans to?
I cannot guarantee.
Okay, thank you.
Yeah.
Hi. Today I'm running Turbonomic
to do load balancing within across clusters. But will this replace turbonomic load balancing for one cluster?
It's the same question. So it's right now it's intra-cluster. It's inside the cluster.
It's exactly the same features, actually.
Same as?
Yeah, it's the same features. The predictive DRS is going to give me the same value that turbonomic is giving me today for the load balancing part.
I'm not sure about what turbonomic does. Or.
All right. Okay.
Hi. In scenario number 2, you mentioned that the new workload will end up in one hypervisor. But what about initial placement feature of DRS? Wouldn't that displace the workload equally on all the hypervisors?
Sorry, can you repeat the question?
In scenario number 2, you mentioned about new workload, where testing the performance, right? So you mentioned that all the new workload will end up on hypervisor 1, let's say, for example. But what about the initial placement feature of DRS?
Yes. So initial placement will actually place them, but when the VM is running, I'd say like there's 8 hours durations where this VM runs.
Yeah.
So during these 8 hours durations, what if the VMs are moved to a different host, right? Because the workload changes, because there are multiple VMs, multiple type of applications running in the cluster. So during this behavior, during this movement, what if all these ideal VMs end up on the same host at some point? Then next time, or probably the next day when they're going to start, PDRS will actually take care of.
Assuming that I don't have a fresh installation of vCenter, I have a lot of performance data in my SQL databases. So why don't you analyze them for the predictions when activating predictive DRS?
So it all depends on VROps, right? Because VROps needs to be reading this data. So the way VROps reads this data is after you install your vCenter and attach it to VROps, that's when it starts reading all of that data.
Okay.
So let me clear one point. So if you already have VROps, like monitoring your vCenter, and you like for more than 14 days, let's say, and if you just go and enable PDRS, you will start seeing predictions immediately because there is already data on the VROps.
Because VROps is already that data. It already has that data. Yeah.
Okay, thank you.
So what's the maximum period you can set for predictions? We have workloads happening only quarterly, end of quarter, for a few days. So what's the longest period you can set, and how does it affect, for example, utilization or load on the VROps side?
What do you mean by priority?
So the period is 14 days, you said, right? The prediction. So, but I have workloads which happening only every third month, end of quarter.
Yes,
so what is the maximum period you can set for predictions?
You can change that, but I think 14 days would still be fine because it is just to see after 14 days of data, it will start giving you predictions. So in 14 days of data, in the last 14 days, if all your VMs are not doing anything, that would still be fine.
No, I think his question is about the longest duration of setting the data.
Because 14 days wouldn't help me if that particular workload is happening every quarter, just once. End of quarter, last few days, financial close, right?
Right. So as far as I understand, there is no longest duration to be set in this case. It's all about learning. So in your case, I think learning will happen over a year. So maybe over multiple years, this kind of learning will come into your VROps. Because the workload is actually spiking, 4 times a year.
Yeah.
If in case if your use case is very specific, there are ways to change this. If instead of 14 days you want to start generating after 3 months, let's say.
Okay.
You'll do that, but probably we can discuss that offline.
No, even if you don't change it, after 3 months or 6 months, it will eventually learn that data.
Yeah,
right?
even if you don't change it,
So even if you cannot do anything within 3 months, because VROps will not have that learning, right? Because your workload is only going up after 3 months.
Okay.
So you need that much time for VROps to learn this pattern.
Regarding this, has the retention period on the SQL database, on the vCenter database, with VROps, is it has to be the data there, or we can purge it out after it learned the algorithm or the pattern?
It collects actually every at 5-minute interval, I think. It collects the stats once a day, and it collects at 5-minute granularity. So if yesterday data will be already in the VROps today. So
Okay.
every day it gets the data from the vCenter.
Okay.
Yeah.
And then it's there, and we can purge the data from
Yes,
the vCenter.
from the vCenter. Yeah.
Okay, cool. Thank you very much.
Hi, I have a question. In your examples, your recommendation for predictive DRS range from 3 to 5. So
Oh,
does
you
that
mean the priority?
Yes. So does that mean I have to turn my DRS all the way to aggressive level 5 to get full advantage?
No. That has nothing to do with priority. Just in my case, the settings were different.
So say at fully at level 3, that will take care of
Yes,
all of
that
the
will take
predictions.
care of it. Yes, exactly.
Thanks.
How would this be applicable to VDI? So where VMs are, say, busy between 9 and 12 in the morning, but the VMs are going to be constantly refreshing or deleting and respawning. Would this be able to cope with, say, the folder?
Yeah, it's a good question. So actually, as we mentioned, the history for the resource usage needs to be in VROps for a certain amount of days. If the VMs are not going to be alive for that duration, then unfortunately they will not be able to get that kind of prediction.
So alive in the sense, are you going to power off the VMs or?
Sorry, what was that?
Are you going to power off the VMs or they're still running?
Non-persistent VDI, right? So they will
VDI
get refreshed. So
okay.
I could see that in the future you might be able to kind of take the prefix of the VM name and maybe store that to be able to put predictions onto pools as they spin up.
Yeah, that's possible.
VM has to be up and yes.
Are you using the UID of the VM for prediction?
Yes. Okay. So yes.
So I might have missed it. The database for this runs on a separate SQL Server database, separate from any other product? Do you have to have a separate SQL Server database?
No, there is database involved for predictive DRS. So vCenter already has its database where it stores the resource usage data. VROps has its own database. There's nothing new that we are adding as a requirement for predictive DRS.
So is VROps run on a Postgres database the way that vCenter is moving to a Postgres database?
Yes. Okay. It's just a flag on existing DRS.
Okay, thanks.
Yes.
Hi. I'm thinking how will it cope with irregular patterns? Like a VM is running hard on Monday, Tuesday, Wednesday, and not running, and then it repeats this, and then let's say it starts moving fast only on Mondays. When will it unlearn that pattern, change the pattern?
Yes. Anyway, it follows a pattern, right? Like Monday, Tuesday, Wednesday, and then Thursday, Friday. It's not doing anything, but it still follows a weekly pattern. So those still be predicted.
Yeah, as long as that pattern repeats, let's say after 2 weeks or 4 weeks, it doesn't matter. As long as that repeats, and that is the periodic, regular pattern, then VROps will be able to learn it. Right. If it changes every week, then again, that's not going to help. At some point, it has to, become a pattern.
Yeah, I see. Okay. Thanks.
I think there's a question.
Hi. I understand that you are getting metrics only 5 minutes, every 5 minutes from VROps or from vCenter to vCenter. Do you have any plans on measuring the impact, the actual impact of a vMotion of a VM? Because you actually cannot see what the actual impact might be for vMotion, and if you are doing this predictive, then you have to really say what the impact is while the VM is vMotioned. So this might be a problem for doing many vMotions in front of the expected
Actually,
spike.
that is not part of PDRS, but you might see it in the future in the DRS itself. So PDRS will only give you VROps will only give you the predictions. So while accounting these predictions and giving you recommendations, that's the job of DRS. So DRS will account all this.
Because DRS considers the cost of vMotion as well in when doing its load balancing. So it's more of a task for DRS to find out the actual estimation for vMotion cost.
So do you have any plans on shorten the time frame, especially for predictive DRS?
I don't know. I cannot.
We are working on it.
Okay.
Yeah.
Good luck.
Thanks.
Does have predictive DRS an impact or suggest to vSphere high availability as well?
No.
Not right now.
For the placement for new
Yeah, not right now.
Okay. Okay.
Yeah.
Is it planned?
Not that we are aware of right now. We could consider that, but not. Yeah.
Thanks.
Yeah.
The questions?
Okay.
Okay, so one more.
How much time do you give the hosts to power up? If you power down hosts with the power management feature.
How much time?
Yeah, I've got hosts that maybe 10 or 15 minutes to power up.
So DPM usually works with the IPMI module on the host, and to issue power off or power on. So it depends. It triggers that through that module. We cannot control the.
It's not a total power off. It's a standby.
Standby.
It does something.
So it's basically the power stage.
Okay.
Yeah.
Okay, guys. Thank you.
All right. You've been a great audience. Thanks. Thanks for all the questions.